Hi everyone, this lesson is a last minute Lucy review for our chapter test coming up. This is for law of sines and law of cosines. So let's get started. Our learning targets are basically just to know when you use law of sines and when you use law of cosines. We're going to use law of sines when mostly we have two angles. So if we have two angles, like if we have an angle, and a side, or if we have an angle, a side, and an angle, we want to use the law of the sines for these two options. And then, of course, for cosine, law of cosines, we want to use if we have two sides. So if you have side, side, or if you have side, angle, side. In both of these instances, for law of the sines and law of the cosines, there is an option for side, angle. Write it like that. Side, angle. You can use either. If you use the law of sines, side, angle, then what you're going to see is on your axis, you're going to see two angles, right, that have the same value. And you have to use that angle plus 180 minus that angle. If you were to use law of the cosines, you are going to use the quadratic formula. Or if you have that, if you have a graphing calculator, you can also do that. And I'll show you how to use the graphing calculator for law of cosines to solve a quadratic. So we're going to start off with this problem. Find the height of the lighthouse. So your job is to find the actual height, this length all the way to the top, that one right there. And so the first thing what we want to do is we want to figure out what information do we know. Okay, we know that this is perpendicular. That means it's 90 degrees. We know that this is 81 degrees. So if that's 90, that's 81. This angle right up here should be just 9 degrees, okay? Because they have to all add up to be 180. For this triangle here on the left, if this is 81 here, right, we can go to our calculator, and you could do this in your head, but you also could go 180, subtract 81, and you're going to get 99 degrees, which means that for this triangle in here, this little part is 99 degrees. Similarly, to find this angle up top, right, you would go 180, subtract 46 degrees, and subtract 99 degrees, and I get 35. So that angle at the very top is 35 degrees also here. So what I'm going to do is, what we need is some additional information for this right triangle. So this one right here, that we're going to use to find the height, that x value there. And we know that this is 81 degrees. We know that that's 9, but we don't have any other side information. We need a side information. So I'm going to use this triangle right here, and I'm going to move that over to the side so that you can see this a little bit better. But it's kind of a triangle. I'm going to use this triangle where this is 46, this is 99, and this is 35, and we know that this side is 20. So we have all three angles. So remember, for law of sines, we just need two angles. We want two angles. That's preferably, because if we have two angles, then we have three angles. So basically what we're going to do is we're going to say sine of 35 over 20. So we're going to say sine of 35 over 20 is equal to, and what I want is this side right here. Let's call that A. I want this side, because if I have that side, then what that means is that I will then have this side. Actually, then I'll have that side. I don't even need this side. I can just use this big triangle right here to find that value, and I don't actually need this information, do I? I can use the big triangle like that. Okay, so let's find little a, and we're going to actually use 46 degrees instead of this big triangle. I like that better. All right, so let's find a. So we're going to say sine of, and this triangle right here, I know that it looks a little odd, so I'm going to draw it not accurate, not to scale, just so that you can see that the 35 angle is opposite the 20, And then if this is 99, the side opposite that is A. And so when you're using law of the sines, you have to use the angle on the opposite side. So you have sine of 35 over 20 is equal to sine of 99 degrees over little a. And that's what we want to find. We're going to cross multiply, and we get a times sine of 35 is equal to 20 times sine of 99. And in doing that, we're going to get a is equal to 20 times sine of 99 divided by sine of 35. Okay, so just keep in mind that you want to use parentheses whenever you can. So we're going to go, let's see, we've got 20 times sine of 99. So I'm going to go 20 and times, and I'm going to type in sine, there's my sine, of 99 degrees. And make sure you're in degrees. That's a big deal. Unless you're going to use a decimal, like a approximation, I'm going to put a decimal point there, and that's going to help give me an approximation. And then I need to divide by sine of 35. So I'm going to take this value, I'm going to go hit the divide button. It automatically pulls up my answer. I'm going to go parenthesis, and I'm going to say sine of, what's that angle? 35. So 35, and hit enter. I get 34.4. And so therefore, my little a is about 34.4. So I'm going to put that back up here, or actually here. So I'm going to say, now I know that this is 34.4. And so now with this information, I don't need any of this stuff inside, which, you know, all right. But what I do know is I know that's 46. From here, that's 46. And what we're doing is we're using this big triangle like this, right? We're using that big triangle. So that's 46. This is 34.4. And so if you're standing right here, this is the opposite side that I'm trying to find, which is the height. And this is the hypotenuse, which I have. So we're going to say sine of 46 degrees is equal to the opposite side over the hypotenuse, which is 34.4. Okay, so we're just going to cross multiply. I'm going to get x is equal to 34.4 times sine of 46 degrees. And I'm going to work that out. Let's see. We're going to go 34.4 times sine. And I'm going to go over here, trick. It's sine of 46 degrees. And since I already have a decimal here, I don't have to put a little point there. I get 24.7. So that means that the height of my lighthouse is 24.7. So about x is about 24.7. We'll call them feet up. Okay? All right. So this problem here, we have Mr. Winterwasher here, and Winterwasher is 5 feet tall, which I guess this means this is a miniature building, because if it's only 5 feet tall, then that's 5 feet tall too. The building 2 stories up is 5 feet tall. Anyway, obviously not drawn to scale, but your job is to find how tall the building is. So we want this big building up here, x. I don't know what x is, so I don't know the whole value, but what I'm going to do is I'm going to find the value from here and call that x, all right? Because I already know that this is 5. And in the end, I'm going to go x plus 5. That's what I want to do. In the meantime, they gave me also the information that the angle of depression is 17 degrees. Now, the key here is to know that the angle of depression is based off of a horizontal, which means that this distance here is based on my horizontal going down. That's the angle of depression. So that's 17 degrees. Whereas this right here would be the angle of elevation. Now, eventually, I'm going to use this top triangle to find x, okay? So meaning this triangle right here, I'm going to redraw it, okay? That's what I'm going to find x. I'm going to use that to find x. So I know that's 32, but I need an additional piece of information. So what I'm going to look for is this value here. I'm going to call this a. I'm looking for this value right here. And when I find that value, then I can use that again to find x. But in the meantime, I'm going to use this bottom triangle here, okay, to find out what this value is A. So I've got, this is right, so I've got the opposite side, which is 5. I've got the adjacent side, which is A. So opposite and adjacent is tangent. So I'm going to say tangent of 17 degrees is equal to the opposite side over little a. I'm going to cross multiply, meaning I'm going to say a times tangent of 17 degrees is equal to 5. So a is equal, so a is equal to 5. So a is equal to 5 divided by tangent of 17 degrees. Make sure you use parentheses. So here we go. On this side, I'm going to go 5 divided by parentheses. I'm going to type in my tangent, 17. I'm going to use a decimal so that it makes it a decimal. 5 divided by tangent of 17, I'm in degrees, and I get 16.4. So A is approximately 16.4, and I'm going to make, that's this value here. And so I'm going to erase this here because I know now that that value is 16.4, okay? So 16.4, and I have this here for the window washer is here. So you're going to find x, so we're going to say tangent of 32 degrees is equal to the opposite side over the adjacent, 16.4. I'm going to cross multiply, so x equals 16.4 times tangent of 32. So x is about, okay, and let's see, 16.4 times tangent of 32. So 16.4 times, and we're going to type in tangent of 32. And it's already decimal, so I'm good there. Close the parentheses, enter. So I got 10.2. So that means that this value up here is about 10.2. But remember, 10.2. Remember, that's not the answer because we want the height of the building. So the height of the building is going to be our 10.2 plus 5. So that's going to be 15.2. I get that this is not drawn to scale, but the point is that you can do the problem. All right, for this problem here, I like this problem. This is our surveyor. And remember, a surveyor's got this tool. It kind of looks like a tripod, but it's way cooler than that. And what you're doing here is you've got these two angles here. So a surveyor can measure this length from, I think this is A to C, and they're trying to find out the distance across the river without actually going across the river. And so what they can do is, based on this length here, they've got these two angles that they have to measure. And so in order to find across the river, right, we're going to use law of sines because obviously we have two angles. And so we're going to say 180, 180, I'm going to subtract 75, and then I'm also going to subtract 60 in order to get the other side, which happens to be 45 degrees. And so therefore this right here is 45 degrees. And so we can use law of sines because we've got the angle and the side opposite. So we're going to say sine of 45 degrees over 300 is equal to, now I want to find x, so I have to use the side opposite that, the angle opposite. So we're going to say sine of 60 degrees over x. So we're going to cross multiply. I know that you guys know the sine of 45 is root 2 over 2, sine of 60, root 3 over 2. I get that. I'm going to use an approximation instead, but you totally can use the roots. It's fine. I guess I can show you that also. I'll do that in a minute. So cross multiply, I get x times sine of 45 is equal to 300 times sine of 60. And we're going to get x is equal to 300 times sine of 60 degrees divided by sine of 45. So if I use my calculator, which I'll do first, I've got, what do I have? What was that? 300. So we're going to go 300 times sine of 60, 60 point, okay. Move that over here, divided by sine, I'm going to go parentheses again. You just need parentheses, you guys. Sine of 45 on the denominator, and enter, I get 367.4 feet. So that means that, or meters, depending on what the surveyor is measuring in, we got 367.4. So 367.4 would be my answer to the distance between A and B. So going through this, right, if I were to do this just in exact values, I would have 300 times sine of 60, which is root 3 over 2, divided by sine of 45, which is root 2 over 2, right? So this is this over this. The 2's are actually going to cancel. And I end up getting 300 root 3 over root 2. Well, of course, I'm going to get rid of this root on the denominator by multiplying by root 2 over root 2. So I get 300 root 6 over 2. Oh, 2 divides into 300. 150 times, so 150 root 6. Let's see, 150, 150 root, where is that? Here? Yep, 6. Let's see what that becomes. 367. See? Either way. All right, next problem. What are the possible values of S? S would be this value here. Also, we need to find the height. Now, you have options here. Now, some of you remember a 30, 60, 90 right triangle, right? If you had a 60 degree, here's 30. Opposite 30 was some value, A, let's say. Opposite the 90 would be twice that value, and opposite the 60 would be A root 3. But if you forgot that, you definitely can still like put yourself here, right? And go opposite over hypotenuse, meaning sine of 60 is equal to the height divided by 18. Cross multiply, the height is equal to 18 times sine of 60. Now, yes, we can do an approximate value of that. Okay, let me do that. 18 times, let's go, sine of 60 point is going to be about 15.6. So H is about 15.6 units. So 15.6. The other thing that you're looking at is I could have used exact values, and so we know that sine of 60 is root 3 over 2. So I could divide 2 into 18, and I get, what, 9 root 3, also equal to 15.6. The other option, remember, is that opposite the 90 is equal to 2a, right? So 2a is 18, which would mean the a value, which is opposite 30, would be 9. So here's 30, right? If it's a 30, 60, 90, which would make that 9. And therefore, opposite the 60 would be a root 3, or 9 root 3, okay? So that's another value. What are the possible values for S? This is the second part of the question. So number one, you had to find the height. You either find the height as an approximation, or you find the height as an exact value. The second part of the question is asking me for values of S. Now, we don't actually know the value, because all we know is that heights come down perpendicular. Check. We know that's 90, but we don't know these angles here. Do not assume that it's 90. Don't do that. So what we're going to do is we're going to say, well, I know that this is a side, and this is a side of a right triangle, or a leg and a leg of a right triangle, and S being my hypotenuse has to be bigger than the leg. So one thing I can say is that S is greater than 9 root 3, or you could say S is greater than, what do we get, 15.6? Okay, so we could say that. The other thing that you can say is based on the larger triangle, right? You've got this larger triangle, that if, let's see, we say, we know this is 60, let's see, that's 18, this is 9 plus some other value, which we don't know, I'll call that value, and here's S. Now, my thought to this is this. Okay, back in the day, when you used to do this, I think you were in geometry, right? And you said the sum of two sides of a triangle has to be greater than the third side. Well, let's say this was 3, and this was 4, and this was 5, right? So I knew that 3 plus 4 is 7, that's greater than 5. 3 plus 5 is 8, greater than 4. And 4 plus 5 is greater than 3, okay? But if I didn't know one of the sides, and let's just say I called it, I don't know, then what I would do is I would say that x has to be less than the sum. Well, the sum is 4 plus 3, so 7. That's the sum. So it has to be less than the sum because it can't equal it, right? It's got to be less than. So 4 plus 3 has to be greater than x, or x has to be less than that. But it does have to be greater than the difference, okay? And the difference is 4 minus 3, which is 1. Obviously, it's got to be more than 1. So that's how we would do it back in geometry. Well, now what we have is s. So s is a value we don't know, but you know that s has to be less than the sum, and the sum is going to be 18 plus 9, which is what, 27, plus some value, and it has to be less than, and it has to be greater than the difference, right? And the difference would be 18 minus 9 minus that value, okay? So that's where we're at with that. So we don't know the answer per se for a number, but I have 2 options of writing these values. Find the area of triangle ABC. So I'm just going to call this ABC. You call it whichever letters in order you want. C is 30. Little a, opposite angle A, is 3. And little b is opposite b, which is 4. Okay? Please don't make the mistake of calling this a 3, 4, 5 triangle, because it is not. Not that we know of. Because 30 would not be 5, right? Because it'd have to be the smallest. Anyway. What do we want to know? Oh, find the area of this triangle. Well, okay. We have different values. We know the different formulas for area, right? We've got 1/2 BC, and then we go sine A. We would go 1/2 AB, and then sine C. Or you'd go 1/2 AC, and then sine B. Now, what we have is angle C. And so remember, all of these letters are different, right? But more importantly, you need the value of, you've got this side, you've got an angle, and you've got another side. So you want, when you're trying to use this formula, one of these, you want side, angle, side, right? Because the other option is to use side, 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 which we don't have this side here. And why would we want to go find that side using a lot of the cosines when we can use this formula? So we're going to say 1/2, the area of this triangle, which is, of course, the space inside, is going to equal to 1/2 the side we have, which is little a, 3. The side we have, the little side, which is 4, so A, B. And then we would say sine C, which is 30 degrees, okay? Well, we know that, yes, I can use my calculator, but, realistically, you don't need it, because you know that 3 times 4, and then sine of 30, right? We should know by now is 1/2. So the 2's cancel. 2 times 2 is 4, right? That's gone. And so my area is going to equal to 3 feet squared. You totally can use the calculator, though, if you don't feel comfortable doing that. So you would say 1/2. So I'm going to go I'm going to say that's a comma. 0.5 times 3 times 4 times sine. So I'm going to go sine of 30 degrees. So I'm going to say 30. And it looks like I already have a decimal here, so don't need to add one, and I get 3 again. Okay? This is a triangular field of grass. Okay? Approximate the number of acres in the field. 1 acre is 4,840 yards. Okay, so basically it looks like we want the area first, right? So let's find the area. The area, I've got all the sides. I don't want to use the other formula because I have 3 sides. So do you remember Heron's formula? Herons, Heron's formula. So to find the area, it's the square root of the semi-perimeter, which I'll talk about in a minute. So the semi-perimeter times the first side, I don't know, call it A, times the semi-perimeter minus the second side times the semi-perimeter minus the third side. Okay, so the semi-perimeter, by the way, semi-perimeter is equal to the perimeter, which is 189 plus 104 plus 145 divided by 2. That's the semi-perimeter. So let's figure that out, okay? That's going to be, here we go, did I say 189? Yeah. Okay, so 189 plus 104 plus 145, and I get that number. I'm going to divide that by 2, so divided by 2, 219. So my semi-perimeter is 219, okay? Which means that my area is going to equal the square root of 219 times 219 minus the first side, which is 189, times 219 minus the second side, which is 104, times 219 minus the third side, which is 145. And luckily, we have this super awesome calculator that will just do that for us. So we're going to go control root. And even though it's a little tedious typing it in, so we got 219. I mean, hey, it's doing that for you. So, you know, what can you say? 219 minus 189, close the parenthesis, add a new parenthesis. 219 minus 104, close the parenthesis. 219 minus 145, close the parenthesis. I don't have any decimals there. So I think what I'm going to do is go back and put a decimal point here. My other option would be control enter and see the little like approximation above that. That's what I would use, but I didn't. So enter. So we get 7,000. What do we get? Area is 7,477.3458. So 0.3458. So that's my area. We're going to call this, we know this is yards. So I'm going to go yards squared. Okay, because area is always squared. So here's the thing. We want to know, what do we want to know? Approximate the number of acres. Well, this is the area, right? And so all we have to do is take this and divide by our 4,840. So take this value. I'm going to go answer. So, if I just hit the divided button, the answer will automatically pull up. See? So answer divided by 4840, enter, and I get 1.5 acres. So, so the acres are about 1.5 acres in this like plot of land. Cool. All right, next problem. It says find the measure of the largest angle. So we, in triangle ABC, so here's A, here's B, here's C. Now, the largest angle is always going to be opposite the largest side, right? So if little a is 3, and little b is 8, and little c is 6, the largest angle is going to be opposite the largest side. So my largest side is 8. So that means the largest angle is B. So I need B. All right, I don't have B. I don't have any of the angles. So that means that I need to use law of the cosines, because the law of the cosines tells me when I have 3 sides, that's what I have to use. The formula that I'm going to use is this. What you need to remember in this, and we are going to give you like a formula sheet, just FYI, but if I'm using b squared, little b squared, because I'm trying to find angle B, which is going to be, a cosine of angle B, These two variables have to be the same letter. I mean, they're not going to be the same size because this is a side and this is an angle, but they have to be the same letters. And then the other letters are just whatever's left inside because, and honestly, it doesn't matter what order you put them in. So that's going to be a squared plus c squared, and then subtract 2 times a times c, and then cosine of b. So that's the formula I'm going to use. So let's plug our values in. So we're going to go 8 squared is equal to a squared. What's a? A is 3. So I always write this like this because I'm going to use the values here. Plus c squared, so 6 squared, minus 2 times a is 3, c is 6, and then cosine of angle b, because that's what we're ultimately trying to solve for. So the first thing we're going to do is we're going to move these two terms here over to the left side. We want to move them that way, right? So that would be 8 squared minus 3 squared minus 6 squared, and then that equals whatever 2 times 3 times 6 is, and then we're going to find cosine of angle b. So let's figure all this out. Okay, so on the left, I've got 64 minus 9 minus 36. So I've got 64 minus 9 minus 36, and I get 19. 19 is equal to 2 times 3, which is 6. 6 times 6 is 36. Ooh, almost missed it, you guys. Almost missed it. You see this minus sign right here? What? Almost missed it. Whoops. Don't lose that. And so that was from here, right? You got to be careful. I almost missed it. There it is. That value here, you have to subtract that. So you move this 30 squared over. So that means you subtracted it. You move the 6 squared over. You subtracted it. But you still have this minus sign, and that's through 2 times 3, which is 6 times 6, which is 36. So that's a negative 36. So now what I have is I've got negative 19 over 36 is equal to cosine of angle B. So that means angle B is equal to arc cosine of whatever 19 divided by negative 36 is. And so let's figure that out. 19 divided by 36. So we're going to go arc cosine. So we're going to go here. Arc cosine of, now I got to do negative 19 divided by 36. I'm going to use a decimal point. Enter. I get 121.9. So that means that angle B is about 121.9. I'm an angle, so it's a degrees. All right, right on. Good. Okay, given triangle ABC, so here's A, here's B, here's C. Oh, find all the sides and angles. So, 30 is A. We know little a is 6, and we know little b is 8. Ooh, this is the ambiguous case because this is side, side, angle. See, side, side, and then angle. Okay. So we got to figure out if there's 1, 0, 1, or 2 triangles. We don't know yet until we figure this out. So we're going to start off with law of the sines. Okay, I'm going to start off with that. And which that means is law of the sines. So we're going to go sine of 30 degrees over 6 is equal to sine of b over little b. See, you got to start off with this angle because you have to use the side or the angle opposite, right? I couldn't use C because I don't have the angle and I don't have the side. So I have to use what I have, which is only the 8, okay? Cross multiply, we get 6 times whatever sine of angle B is. That equals 8 times sine of 30, which, right, is a half. So sine of B is equal to a half of 8, which is 4, divided by 6. So that means angle B is equal to arc sine of 4, 6. So I actually want that value, what 4, 6 is. So 4 divided by 6 is 0.6667. So this means that 0.6667. I want to know where sine is about 0.667. So this right here is really important to know this number. And I know you might be thinking, why did she do that? Why didn't she just type in 4/6? I need this number here. The reason I need that is because I need to ask myself, where is sine 0.666, right? So I'm looking at visually, I'm looking at this angle here. I'm thinking sine starts at 0, goes up, comes down, and ends, right? We know that the range goes from -1 to 1, okay? So what I'm looking for here is where, this is what this is asking me, where is sine 0.666? Well, this is about 0.5, so I'll go up a little bit. There's 0.666, so this is 0.666. This point here is where I'm at. It's also here, all right? So when I type this into my calculator, let me show you what I get. So where is sine 0.666? So I'm going to say trig arcsine of, now I can just type in 4 divided by 6 because it's the same value. I think it's a little easier. Actually, I could have typed in answer, 41.8. So that means that the measure of angle B is about 41.8 degrees. So this one right here is about 41.8 degrees, okay? That's this right here, 41.8. But it's also right here. And to get that value, you know this is 180 degrees. You know this is 360, right? That's 180. To get this value, if this is 41.8, all I have to do is go 180 subtract 41.8 degrees. So 180 minus 41.8, use my calculator again, 180 subtract 41.8 is going to give me 138.2. So the other angle is 138.2. So that means, or the measure of angle B is equal to 138.2. Now, not always are these angles going to be, create a triangle. But what we have to do now is I've got to make another triangle. Here's A, here's B, here's C. We'll call these prime, okay? And by doing that, we still have A is 30 degrees. We still have little a is 6. We still have little b is 8. But instead of this being 41.8, this angle, obviously not drawn to scale, but that's okay, is 138.2. Now, 138.2 plus 30, right? What is that? 168.2. So 180 minus 168.2 gives me 11.8. So this triangle exists, right? 11.8. We can say, hey, we got two triangles. This triangle here, I still need this angle. So I'm going to go, I guess I should use this one. Sorry about that. I was using my own calculator. 180, subtract 30, and then subtract, what do we get? 41.8 gives me 108.2. So what that means is this little angle here is 108.2 degrees. So what we have is, two different triangles now. So what I need to know is what's little baby c here, okay? And I need to know what's baby c here, two little c's. And they're going to be different because these angles inside are different, right? All these are different. So what I have to do now is I can use law of sines, we like law of sines, to find little c. So the first one for the top triangle, this is the top, we would go sine of 108.2. Remember, you have to do this side and that, right? So sine of 108.2 over little c is equal to, now I can do this, I can use these two, or I can use these two. And I'm going to, of course, use those two because those are easier. So sine of 30 over 6. So I'm going to cross multiply, right? I'm going to go c times sine of 30, which is a half. So c times a half equals 6 times sine of 108.2. and multiply by the reciprocal. So C is going to equal to 2 times 6, which is 12, times whatever sine of 108.2 is. Okay? So that's going to be sine. So I'm going to go sine of 108.2 gives me that, and I'm going to multiply that. So I'm going to go times 12, and I'm going to get C is 11.4. So this C on the top is about 11.4, okay? So this C is approximately 11.4. Okay, that's a little weird. Let me rewrite that. So 11.4. And then the other one down here, let's use a different color. I'll use red. We're going to go sine of this angle here, because in order to find C, I need to use that. So 11.8 over C is equal to sine of 30 over 6. Cross multiply, I'm going to go sine of 30 times C, half times C is equal to 6 times sine of 11.8. Again, C is going to equal to 12 times whatever sine of 11.8 is. So on my calculator, I'm going to go sine, so trig, go sine of 11.8, and equals, and then I'm going to multiply that by 12, and I get 2.45. So this is going to be approximately 2.45, and so that's my other C value. Okay? I do want to say this one thing. We were given this triangle. This was a side-side angle triangle, and I did say that I would show you how to do this again. So what I'm going to do is I'm going to bring in another page. So give me 1 second. Let me see. So bring in another page. I need to move this back. It's a little hidden. Let me see. Go back up here because I need this information. So I've got 30 and then 6 across from that and then 8. So I might have to do a few things here, but we'll see. So we've got 30. I said A, we have B, and we have C. And this was 30. And let's see, what was that? 36 and then 8. 36 and then 8. Okay, so I'm going to show you this with law of the cosines. To use law of the cosines, you actually need, you can only have one unknown value. And so we don't know C, we don't know B, we don't know little c, right? So what you would do is you have to use these two, all right? And so even though I don't want that, to solve for that, that's what I would have to use, okay? So I would go 6 squared is equal to, right, the other two sides, which is C squared plus 8 squared, minus 2 times C times 8, and then cosine of the angle that I know. Let's work this out. But the first thing that should sort of be of an alert to you is this C squared. And you should know that when you have a C squared, that means it's quadratic, which means you need to set the equation equal to 0. So I'm going to move the 6 squared over. So I've got C squared plus 8 squared, which is 64. Move the 6 squared over, so that's minus 36, right? And then I've got minus 2 times 8, which is what, 16? 16 times cosine of 30. So I'm going to use my calculator. I know cosine of 30 is root 3 over 2, but I don't want to use that. So I'm going to go cosine of 30 degrees, point. And I want to move that over and go times, is that times? Yeah, 16. So I get 13.9. So minus 13.9, and I still have this C here, so C. So what's happening here is that, because this is one term, you guys, right? This is one term. 2 times c times 8 times cosine of 30. Well, 2 times 8 times cosine of 30 is 13.9. You still have the c. All right, I'm going to rewrite this. So 0 equals c squared minus 13.9c. And then 64 minus 36, right? What is that? 64 minus 36. That's what? 5, 2, 8, 28. So 64 minus 36, so plus 28. All right, so yeah, you can use the quadratic formula. So x is equal, or c is equal to the opposite of this value. So that's 13.9 plus or minus the square root of, b squared, negative 13.9 squared minus 4 times a, which is 1, which is in front of the c, for a c, 28, all over 2 times the value in front of c. Okay, so yeah, use your calculator, no problem. But I want to show you how to do this on the calculator. So the rule is, the first thing we're going to do, let's see, hopefully this works. Menu? Yeah, menu. And we go to step 2 is algebra. So menu, algebra. And you think you want to do solve or zeros, but you don't. You want to go all the way down to polynomial tools and then find the roots. Check. Yes. And that's 2. So is my degree set 2? Yes. Is it real? You have to tab through this, because if you arrow down, it decreases the root, right? It goes down to 1. So I'm going to tab through that. Real. Yes, I want real values only, because otherwise it's not a triangle. Okay. So now it's asking me, what are the values of A, B, and C, or the values in front of these? So the value in front of C is 1. The value in front of the C here is negative 13.9. And then the value in front, and that's just 28. Boom. Let's see what happens. And enter. What did we get? Oh, we got 11.4 and 2.4. So I don't know what we get. For C, we got about 11.4 and 2.4. Oh, and those were our values for C. So that's exactly what we wanted. So that's cool, okay? Because remember, when we did this, right, we got 11.4 here when we did this before, and we got 2.4. So we did all of that, and that's kind of cool. What that didn't do, though, right, what it didn't do was it didn't give me all the angles. So if I had to find all the angles, then I do need to use the law of the cosines. One other option, too, and I know I'm probably spending too much time on this, so you can just fast forward. But I did want to show you, just to remind you, that you can also do this. Let me shrink this up. You can also do this on your calculator that is not a TI-NSPIRE, but that's the TI-84 Plus. And the formula that I use for this, I'll show you in a minute. But I got quadratic formula, press enter, and it's like, okay, run. What's A? A is 1. What's B? B is negative 13.9. So you have to be very careful and use the negative sign instead of the minus. So negative 13.9, enter. And then C is 28, enter. There we go. 11.45 and then 2.4. So, you can use the calculator on the SAT and the ACT. You should know how to do this. And if you don't know how to do this, come and find me and I'll email me, ask me, all of you. If you want the program, I'll tell you what it is. It is that. Okay? So take a picture of it, whatever. You just have to type it in. The place where you would find prompt and display, and these values, like this arrow here is down here where it says store. You see that down here? STO with the arrow going that way. Prompt and display are in the input output. And that would be if I go to program and I go over to input output. See, there's prompt, there's display. So you got it. Okay, cool. Moving on. All right, so a motorized sailboat leaves Naples. Florida, not Italy. So let's draw our boat. Here's our motorboat. It's got a sail there, so it's a motorboat with a sail. Okay, there it is, and it leaves Naples, Florida, and it's supposed to come down here to Key West, but unfortunately there is a crosswind, and the crosswind pushes you over this way, and now you're here. Well, they want to know how far you're off course. And it does say, what is this, right? And goes up like this. And this is 20 here. What else do I know? We know this is 150. Gosh, it tells us to find X. What else do I know, though? Do I know anything else? Oh, I know this is 60. Right? They gave me 60, they gave me 150, which is this length, and they gave me this angle is 20. Well, all right, I just need to know what X is. How far am I off course? All right, because this is Key West, right? And so I need to know this length right here. I have side, I have angle, I have side. So in order for me to use side, angle, side, two sides, law of the cosines. Oh, goodness. Okay. So what we're going to do is we're going to go X. Remember, when you're using the law of the cosines, these have to match up. And so this is going to be X squared. And then way over here will be cosine of 20 degrees. And then what's in the middle is the sides. So you've got 60 squared plus 150 squared minus, and I'm running out of room, so I'm going to move this over. So minus 2 times 60 times, I'm still running out of room, times 150 times cosine of 20 degrees. So again, super cool that we have a calculator that does all this super fun stuff, was we're going to square root this, right? Because in order to get rid of this x squared, we're going to square root that. And all of that stuff, all of this right here, is going to go in here. That's where that goes. All right. And so let's see if I can just type that all in. Let's see. So we're going to go second. I think it's there. Yep. And I'm going to go 60 squared plus 150. So 150 squared minus 2 parentheses times 60 parentheses, start a new parenthesis, 150 parenthesis, cosine, so cosine of 20 degrees. Oh, there's no decimals here, so I'm going to put a decimal. Am I in degrees? Check. Yes, check. And I think, yeah, just enter. 95.8. So we are, X is about, what did we get? 95.8. I think that's right. Okay, hopefully. Miles off of where we're supposed to be. So, last minute loosely exam. I hope this was helpful to you. Good luck. Wishing you the best of luck on your exam. And hey, see you in class. Thanks for watching.